Hi ladies, it's Mr. O'Sullivan. Today we're going to be looking at lesson 5-2, systems of equations by using elimination. So this this lesson is going to be focused on a new method of solving systems, and that's going to be elimination. So the past few days we've learned about substitution. Today we'll be learning about elimination. So today's LT is I can solve a system by using elimination, and we now know that there are two methods of solving a system of equations algebraically: substitution and elimination. Substitution is easiest of the methods when one of the variables is already alone. So if you already have something written as y equals or x equals, you want to use substitution. And elimination is the easiest of the methods if there's no variables alone. So if you look at these three examples we're going to be doing today, none of those variables are by themselves. There is no x equals, there is no y equals. It's all x plus y equals a number. So whenever it says solve algebraically, you get to use substitution or elimination. You get to decide. All right. So the goal of elimination is to get rid of or eliminate one of the variables by adding the equations together. So we're going to be adding the equations together. So the first thing we do is we always just go ahead and add them. What I recommend is look at your x's, see if they have the same number. Look at your y's, see if they have the same number. Don't care about these numbers. Don't care about these numbers at all. You only care about the numbers attached to your x's and your y's. So if I look, I really have a minus 1y here. Okay, so let's look at this example. So I have 2x plus 5y equals 3 and negative 2x minus 1y equals 5. The first thing I'm going to ask you is look at your x's. What are those coefficients? There are 2 and a negative 2. Look at your y's. What are the coefficients? There are 5 and a negative 1. So if I look, I always want to eliminate something that has the exact same number but opposite signs. So if I look, my x's have the same number or the same coefficient and opposite signs. They're opposite. I have a positive 2 and a negative 2. This is how elimination works. I simply add them together. So I have 2x plus 5y equals 3 and negative 2x minus 1y equals 5. I have to ask myself, what's 2x plus a negative 2x? Well, I know that 2x plus negative 2x is 0x, so they cancel each other out. I now need to ask myself what 5 plus a negative 1 is, or what 5 minus 1 is. Well, 5 minus 1 is 4. So I get 4y equals 8, because 5 plus 3 is 8. This now becomes a one-step equation. Divide both sides of your equation by 4, and I get y is equal to 2. Here's the issue. I have a y value. I need an x value. So now we got to pick which equation we want to work with. We can do our 2x plus 5y equals 3 or our negative 2x minus 1y equals 5. I personally would do this equation, equation 1, because everything's positive. So I rewrite that equation of 2x plus 5y equals 3. And everywhere I see a y, I'm going to substitute a 2. So I have 2x plus 5 times 2 equals 3. 5 times 2, that's a 10. So I have 2x plus 10 equals 3. Got to get rid of my 10 by subtracting, so I subtract 10 from both sides of my equation. And I get 2x equals negative 7. Divide both sides by 2. And I get x equals negative 7 over 2. Or you can write it as x equals negative 3.5. My final answer would be negative 3.5, comma 2. Pay very close attention to this equation. Pay very close attention to this equation. So now let's go on to our next example. I'm going to give you a moment to sort of figure out what you want to eliminate. So let's look at our next equation. We have 2x plus 3y equals 17 and a 5x plus 6y equals 32. I'm looking at these. I got a 2 and a 5. Those aren't the same. I got a 3 and a 6. Those aren't the same. And everything's positive. I want one negative. So I want to ask myself, what do I want to eliminate, my x's or my y's? I'm just going to eliminate my x's. So when I eliminate my x's, here's what we do. I have a 5 right here, so I'm going to put a 5 in my first equation. I have a 2 right here, so I'm going to put a 2 in my second equation. Here's the issue. If I keep them both positive, everything's going to stay positive and nothing will eliminate. So what I'm going to do is make my 2 a negative. Now that we have our numbers on the outside of our equations, we're now going to distribute. So 5 times 2 is 10, so I have 10x plus 15y equals 5 times 17 is 85. Negative 2 times 5 is negative 10x. I already know this is going to work because those will eliminate. Negative 2 times 6 is a minus 12y. And negative 2 times 32 is negative 64. I now see that I'm going to have some eliminations. 10x plus a negative 10x is 0x, so I don't even bother writing it. 15 plus a negative 12 is a positive 3, so I have 3y equals 85 minus 64, which is 21. Divide both sides of your equation by 3. And I get y is equal to 7. Here's the issue. I need to know what x is. So I'm going to choose one of my equations. I'm going to choose my first equation because those are tinier numbers. Always go back to your original equations. So I have 2x plus 3y equals 17. I know that y is 7. So I have 2x plus 3 times 7 equals 17. So I have 2x plus 21 equals 17. I have to get rid of my 21, so I'm going to subtract both sides of my equation by 21. So I get 2x equals negative 4. And then I divide both sides of my equation by 2. To get x equals negative 2. And that's your final answer, negative 2, 7. Let's go on to our final example. In our final example, we have 2x plus 3y equals 16, and 5x minus 2y equals 21. The first thing I have to ask myself, what are my coefficients? I have a 2 and a 5. That doesn't work. I have a positive 3 and a negative 2. This I actually like. And here's why. Because one of my numbers is already negative. So I don't have to end up distributing a negative. So I'm going to eliminate my y's. So when I eliminate my y's, I'm going to multiply my first equation by 2, because that's what's attached to this y. I'm now going to multiply my second equation by a 3. The reason why I'm not multiplying by a positive or a negative is because one of them is already a negative. So I now distribute my 2 to each term, and then I distribute my 3 to each term. So I get 2 times 2, which is 4x, 2 times 3, which is 6y, equals 2 times 16, which is 32. 3 times 5, 15x. 3 times negative 2 minus 6y. If you look, it's already going to work because those y's are going to eliminate. I like this. And then 3 times 21, which is 63. Now we add our equations together. 4x plus 15x, 19x. 6y minus 6y gives you a 0y. So I have now 32 plus 63, which is 95. Now divide both sides of your equation by 19. And I get x is equal to 5. So now we want to solve for y, so we have to choose one of our equations, our first one or our second one. I'm going to choose the first one because everything's positive. So I have 2x plus 3y equals 16. So everywhere I see an x, I'm going to plug in at 5. Two times 5 is 10, so I have 10 plus 3y equals 16. Got to get rid of that 10, so I'm going to subtract 10 from both sides of my equation. So I get 3y equals 6, and then divide by a 3. So I get y is equal to 2. My final answer is 5, 2. And that's it for today. If you have any questions, email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.